We have Dr. Peggy Norris coming to us from the DUSEL Underground Laboratory in Leeds, South Dakota. Dr. Norris is Deputy Director for Education and Outreach for the Sanford Underground Lab. She received her education at Rice University and Columbia University in physics and chemistry and has worked for more than 25 years at the Lawrence Berkeley National Lab in the area of low-energy nuclear science. Lots of exciting things happening not too far south from us, and then definitely underground. So, Peggy, thank you very much for joining us today, and go right ahead.
All right. Am I coming through good on the audio? Can you hear me? Yeah, okay. So I'm going to talk today about our plans for the Deep Underground Science and Engineering Laboratory out here in Leeds, South Dakota, and also our plans for the Sanford Center for Science Education that will be hopefully part of this exciting laboratory. We have a pledge from a private citizen for $20 million for the Education Center, presuming that DUSEL gets its final funding from the government, which they're working through some issues at this point, of course, with the federal budget and so forth. But it's in the design phase. There's early activities now, and that's what I'm going to talk to you about today. As we plan for this Sanford Center for Science Education, we're planning for it to be as the gift agreement says, a transformational center. And given our location and the remoteness of the science that's going to be done, we feel that cyber learning is going to be ultimately very important. And as we plan for our physical center, we want to include at all levels capabilities for state-of-the-art cyber learning. So what DUSEL is, it's an underground laboratory for mainly physics is the funding driver, but it's a great laboratory in addition for geosciences, for biology and engineering studies. It's being planned for the former Home State gold mine. If you've ever been up in the northern Black Hills, you may have gone through Lead and seen the open cut there. The gold mine closed in 2001 and left 370 miles of tunnels, which are called drifts in mining parlance, all the way down to 8,000 feet below the surface, so almost a mile and a half. And that's deeper than 6.5 Empire State Buildings. So this gives us the potential infrastructure for a major underground laboratory. And there's a lot of history to the area, both from the mining standpoint and from the science, and here's just some pictures. The mine ran beginning in 1877 for 125 years. It was one of the major producers of gold in the United States for all of those years. And then the price, and in the 1980s, there's a couple pictures down here in the corner, there was a major science experiment that the Home State Mine agreed to host. They built a cavern for the famous Davis-Bacall experiment, where they put 100,000 gallons of dry cleaning fluid in this big tank underground to look for neutrinos coming from the sun and to try to understand to test whether we really understood the nuclear reactions happening in the sun. Well, it turned out that experiment ran for like 20 years and came with results that were totally unexpected, and that was that something was happening to the neutrinos that they were looking at between the sun and here, and that led to many of the present planned physics experiments for the underground lab. So this is what this bottom middle picture is what the tank looked like when they finally got back into that area in 2009. When the mine closed and the company left, they turned off the pumps and it started filling with water. mostly rain runoff through the open cut, and it still has water up through about the 5,200 foot level, and but they've pumped many levels out, and they're getting it ready for early science now. So what do they want to do there? Well, in physics and astrophysics, they want to answer major questions about our understanding of the universe, what it's made of, how it evolved, why is there no antimatter in our matter-dominated universe, what is this thing called dark matter that we know is 26% of the universe compared to 4% of everything we can see. Okay, and so they're asking those kind of very major questions that will help us better understand the origin and the fate of our universe. And they're starting experiments now. This is just a picture of an experiment that's going to go in next year called the Large Underground Xenon Experiment. It's a search for this thing called dark matter. Right now they're getting the detector going on the surface, and they'll be going underground with it hopefully the end of 2011 or early 2012. And this is the group of collaborators from all over the world that are involved with that experiment. In the geosciences, there's many things that you can ask, and the major questions are about subsurface processes, about water moving through rock, about the movement of the rock itself. Can you predict earthquakes? How about drinking water underground, and so forth. So there's a lot of geosciences studies that are going on now in these 300 miles of tunnels. And here's just some pictures. The universities involved at the moment are the South Dakota School of Mines, Fermi National Laboratory, University of California at Berkeley, Lawrence Berkeley Lab, Montana, and Wisconsin have all been involved to date in doing geology studies underground. There's biology going on underground. There's things living in the rock and living off the rock, bacteria and fungus. And they're identifying all kinds of new species as they go into these areas for the first time. And so there's a lot of questions about things like the interaction between biology and geology. There's this whole new, a relatively new sub-discipline called geomicrobiology that looks at how the rock and the bacteria interacts. And they know that bacteria lives in the rock 8,000 feet below the surface where it's 135 degrees. They would like to drill down another 8,000 feet and see how deep it goes. And that could answer a lot of questions about how life evolved, how it might evolve on other planets, and so forth. So here's some of the groups working on biology. Black Hills State University, our closest neighbor to the laboratory. South Dakota School of Mines again, South Dakota State, Princeton, Tennessee, and Oak Ridge National Laboratory are all doing biology underground now. And then there's engineering. There's a lot of questions both in building the laboratory, but in the process of building the laboratory, you can also study how to best build large structures underground, which could be useful in the power industry and things like that. So they're looking at the mechanical properties of the rock, how it moves, how technology can lead to being safer underground, how the water flows, and so forth. So on the world stage, if DUSEL gets built as presently planned, it's going to be the major underground science laboratory in the world. So okay, so DUSEL is the red Christmas tree ornaments there, and the very largest one will be the campus at 4850, almost a mile below the surface, and then there's a smaller campus planned for 7,400 feet below the surface. So that would have been the deepest laboratory in the world, but China announced a couple of months ago that it was going to build a very small lab deeper, so we don't have the we can't make that claim, but it will definitely be the largest laboratory in the world in its present design. And the location is right here very close to the Wyoming border in the northern Black Hills. It's not that far from western South Dakota. I've made a few trips lately, western North Dakota. I've never been to North Dakota in my life until last month, and now I've been up there twice. It's not so far to Bismarck, and but we are remote, and that is one of our issues in doing the design for the science education. So what we're planning for the Sanford Center for Science Education is, this is our mission, to engage and connect diverse audiences of students, educators, scientists, engineers, and the general public to inspire and prepare future generations of scientists, engineers, and science educators, and then to deepen public understanding of science and engineering. But we're not planning on doing all science and engineering. We're planning on focusing on this draw of the science and engineering to be done at DUSEL, which is very broad in itself, but also the setting within the Black Hills. And you guys are probably quite aware that many of the American Indian tribes in the region consider the Black Hills very sacred and consider that the mining was a blemish on this sacred land. And we've been looking at how we can make the science education a way of healing some of those wounds in some way. And one thing we're looking at is while science and engineering are considered very Western science and engineering are considered very independent of place and time, how we deliver the science education really needs to reflect our place in the Black Hills and in South Dakota. And so we're looking at as we develop programs and exhibits and off-site programming and distance learning, that everything is kind of delivered with an acknowledgement and input from the American Indian communities that are in the region. So just in context, we have these contemporary influences of a international community of scientists, tourists that are very dominant in this region in the summer, and then we have national and international just science enthusiasts. On the other hand, we have the very rural area where we are with the mining culture, with the regional tribes, and with our rural culture. And we have to bring all that together in delivering this science education center. So that's the challenge that we've had in the design of it. So, no, there we go. Okay. All right, so the challenges and opportunities then are to create this modern, innovative science education visitor center while still respecting and embracing the history and culture of the region. And then we have the challenge of the remoteness of the location geographically and the remoteness of the science vertically. So we have to solve all those. And we've been doing a lot of planning and looking at audiences for this center, from casual engagement up through committed engagement. So there will be research opportunities here. At the moment, we have a few every summer for undergraduates, but we want to expand that to high school students, to teachers. We have workshops both on-site and off-site, and then we have casual visitors and tourist programs, classroom visits with maybe younger students and so forth. So we have a wide range of audiences we're planning for.